This is activity 8.2, which is rotating a segment. So instead of rotating a triangle, which we just did, now we're going to rotate a line segment. And this line segment, we're going to rotate at 180 degrees every time. But we're just going to choose different centers of rotation as we do this. So in the first case, we're going to rotate at 180 degrees around point D. And you're going to see that it always lands on the opposite side. We're going in the opposite direction, and it depends on where the center of rotation is, where it lands in the grid. But if you rotate around D, so it's 2 units, you can look at it as 2 units from C to G and G to D, and just count 2 more units in the opposite direction, or you can count the grid like we have in the past. So this is 2 units up and 4 units over, 1, 2, 3, 4, and you just rotate that around 180 degrees. And now you're going to count 4 units over in this direction and 2 units up. And so you're going to end up right there. And so draw the line, and you'll see that a 180 degree rotation around point D lands you going in the opposite direction and attaches to the end of the first line segment. So now we're going to rotate around point E, and you're going to see that it's going to land each time you can draw a line right through from the center from the point that's being rotated through the center of rotation, and then exactly on the other side when it's a 180 degree rotation. So you're going to see that you can count, first of all, 1, 2, 3, and 1, 2, 3, and then count up 1, 2, 3, 1, 2, 3, and you end up at that point. Now if you connect the corresponding points, so C with, probably should call this C prime up here, you're going to see that the center of rotation is at the midpoint. So you do the same thing for G, count up 2 over 1, and count up 2 over 1, and connect the corresponding points. And the center of rotation is at the midpoint, and they of course intersect because it's the same center of rotation. And finally around, rotate point D around E. So just count 1 unit as a diagonal, and then 1 unit past the center of rotation as a diagonal, connect them, and again, the center of rotation for a 180 degree rotation will always be the midpoint of the line that connects the corresponding points. So once again, the center of rotation for a segment that's rotated 180 degrees will always be the midpoint of a line segment that connects the corresponding points. And there's the line segment, that's the rotation, FB, and it's also parallel. We're going to come back to that in a moment. So the 180 degree rotation always ends up with the line that's being rotated, ends up being parallel to the original line. Okay, finally, what happens if we rotate it around G? Well, it's like a propeller. It's just going to flip all the way around. C is going to go to D, and D is going to go to C. But notice that the center of rotation is the midpoint between the line that connects the corresponding points. So C and its corresponding point is going to end up down here. So that line, that center of rotation is the midpoint between those 2 points. So go up 1 and over 2, up 1 over 2 again, and you end up where D goes to C and C goes to D. C goes to D, and there's the line again. So notice that in every case, the line that was the result of the 180 degree rotation is parallel to this original line. So this is parallel to this line. This is the same line basically. It's just moving the opposite direction. The points are, but it has to be parallel. And finally, this one is attached to the end, but it's also parallel to this beginning line. So rotations of a line segment.